Okay, boys and girls, here is your Chapter 6 test review. And I'm talking to the laptop and not looking at the screen. It's very weird. Here's the format of your test: 10 true or false, 10 multiple choice, and 5 free response. This test is not going to be as difficult as our tests have been in the past.
Yes.
I'm not going to use the other test bank that I was using that's made by the publisher of this book. Well, it's not really high five worthy because we're not going to be as well prepared in the spring as we would have been.
It's okay, I just want it.
So, I'll try to find some harder questions. But it's just not as hard.
It's fine.
It's not as difficult. So, anyway, here is the stuff you need to know. In the true-false section, you need to know discrete random variables are countable and continuous random variables are measured. They can take on any value.
Can you give us an example?
I can give you an example. If you went to QT and you counted the number of gas pumps that they have, would that be discrete or continuous? That would be discrete. If you went to QT and you filled your car up with gas, would the amount of gas that you put in your car be discrete or continuous? It would be continuous because the volume could equal any number in a range, like along a number line, anywhere from 0 to the capacity of your tank, the volume of gas could be. So you couldn't count it. So that is continuous when it can take on any value.
But the gas thing counts it for you.
And that's like what you. But it could be like any decimal place.
Yeah, they cut it off at 3 decimal places. But it could be an infinite number of decimal places after that. You have to know your linear transformation formulas.
Still true and false.
Yes, still true and false. I will let you know when the questions change. So here's one set of formulas for linear transformations. Mu sub y equals a plus b times mu sub x. And sigma sub y equals the absolute value of b times sigma sub x.
If we just know, do we have to know those if we know the rules that we learned last semester since it's the same thing, or do we need to know those specific? I just know adding only affects the mean, but
Right.
I know that.
You need to know the formulas. There are 2 formula, maybe even 3 formula questions in the true false. Saying this is the formula for this. And you say true or false. And then when we get to free response, you'll have to use these. Let's see what other fun stuff we have. There's a question about standard normal distribution. So just remember what standard normal distribution is. Not just normal, but standard normal. It has a mean of 0 and a standard deviation of 1.
At this chapter.
We did when we talked about using binomial to approximate the normal. Then we use a z-score to standardize it. And there's going to be a probability question like that. Is everybody good?
No, she has these locked. She has 2 done.
I thought the wheels would roll better. Clearly. It's not paused. You'll have to fast forward through this part.
So on the video, we'll be able to hear everything we're saying.
I don't know. I don't think we'll be able to hear you. The microphone's like right there. I think that's the camera. I don't know. Anyway. You have to know how to calculate the mean and standard deviation of a discrete random variable. Do we remember how to do that? We don't. We should remember then. And there's a part where the writing's going to be bad. We would do what? We take the value minus the mean. We multiply times the probability. And then what do we do? Added them all up. And that's how we found mean. We took the value, subtracted the mean, multiplied by the probability, and then we added them all up. Do you remember how we found standard deviation?
Wait, I thought you just did the value times.
Oh, I started doing standard deviation, didn't I?
Yeah, I thought it was just.
Oh, we'll have to start over. All right, we have to start the video over. No, I'm kidding. We're not going to start the video over. No, it's just x times the probability of x. And add those up. And then, so that's the mean. It's just the event times the probability and add them all up. And then standard deviation, we had to find the variance first. And we did the variance by doing the value minus the mean, squaring it, and then multiplying times the probability of x. And then add it up. And then you take the square root. When I use the computer in the ceiling, does it have the ghost images? Or is that only on the docking station?
I can see it. Well, I don't. I thought it was just me, like, freaking out.
Oh, whoa.
No, Sam.
Sound
Not just you. I think it's the docking station. I don't think I get those ghost images from the projector with that one. All right, recall that probability differs for discrete and continuous random variables. So remember, if you're discrete, that the probability x is less than 5 and the probability that x is less than or equal to 5, those are different. But if you're continuous, then the probability that x is less than 5 is equal to the probability x is less than or equal to 5. Do we remember why that's true?
Because there's infinite, like, numbers.
The area under the curve.
Yeah, I like Virginia's better. The area under the curve at a single point is 0 because a point has no width.
Wait, why? Say why again.
I can say why again. If I look at a continuous function, a graph like this, the probability is the area under the curve. So let's say I'm doing the probability between this point and this point. And the probability is all that stuff right there. All right, the area under the curve. But if I looked at one at just a single point of, say, where x equals 5, then there is no area on that line. That line at x equals 5 has no area. So there's no probability. So that's why for continuous they're the same, but for discrete they are different.
So why does it have the area?
Well, Sam, it's just like a rectangle, and the width is 0. So you do length times width, but 0 times whatever the length is 0. Right. For a single point, the area under the curve is 0. Know the definition of a random variable, and then I typed it out for you. Aren't I nice? It's a variable taking numerical values determined by the outcome of a chance process. I didn't close my parentheses, though. That looks bad. And then I missed. Better. That might be it for the true-false questions. We're still on true-false. I know you have 25 questions tomorrow. 50 minutes, so that's about what? 2 minutes a problem?
Wait, can you go back to the past?
I can go back. I don't know how fast. All right, on the next page, there's a couple of more formulas to remember about combining random variables with addition and subtraction. Still true, false. Does everybody understand the notation that I've done here? If I'm going to add the means, then mu sub x plus y is equal to mu sub x plus mu sub y. If I'm going to do the difference, mu sub x minus y, then the mean is mu sub x minus mu sub y. So the top signs line up with the top signs, and the bottom signs line up with the bottom signs. So I used to always write the sum and difference of two cubes. A cubed plus or minus b cubed is equal to, let's see if I remember that formula, a plus or minus b times a squared minus or plus ab plus b squared. I haven't taught Algebra 2 in a while. But I think those are right. Do you know how we could find out if they were right?
Google it.
No, don't Google it. Multiply them together. Google it. That was Sam that said Google it.
Yeah, do I know that bottom part or no?
No, that was just for me, for fun.
That's
To
fine.
pass the time while you're writing.
That's cool, Mr. Rogers.
You know it. All right. Everybody got those formulas down? Now we're on to the multiple choice section. You have to discern between discrete and continuous random variables. So just like the game we played a minute ago at QT, volume versus number of pumps. If I can count it, it's discrete. If I measure it, it's continuous. So what would height be? Continuous. What about shoe size? discrete. It can only take on certain values. Like, I don't know the smallest one, but it could be 1, 1.5, 2, 2.5, 3, 3.5. There's nothing in between. It's just those certain values.
Well, isn't there like a certain value for height and weight here?
Say that again?
Isn't there like a certain unit for height and weight, so those could be discrete also?
The height and the weight's not discrete because there's an infinite number of values it can take. Now, granted, you might step on the scale, and the scale only measures to the nearest pound. But it's gonna be continuous. All right, more multiple choice fun.
Specified on a problem, like height or weight on a scale.
No, it'll say weight in pounds, and it'll be continuous. Anything you measure, Sam, is gonna be continuous. Find the possible values for an event. Rolling 2 dice 5 times, for example, getting a sum of 3. It's impossible to roll 2 dice and get a sum of 3.
Get a sum of 3.
Do that?
No, it's 5 independent events.
Oh.
It's 5 independent events. So what are the values that X could take? Is it possible if you redo that 5 times and get no 3s? So X could equal 0. Is it possible I do it 5 times and get 1 3? Then X could equal 1. Is it possible? Yeah, it's possible for me to get 5 3s in a row. That wouldn't be likely, would it? What would be the probability of rolling 5 3s in a row? How many different ways can you get a 3? A 1 and a 2, or a 2 and a 1? So it's 1 over 18 is the probability of a 3. So it'd be 1 over 18 to the 5th. I don't know what 18 to the 5th is.
Wait, what did you just tell us? Where'd the 1 over 18 get all the possible outcomes?
When you roll 2 dice, there's 36 possible outcomes, right? Because 6 times 6 is 36. And there's 2 possible ways to get a 3. A 1 and a 2, or a 2 and a 1. And so 2 over 36 simplifies to 1 over 18.
It's basically 0.
It's basically 0. But you're not concerned with that part, really. That was, again, more fun for me. You're concerned with that part. Remember the area under a curve represents probability for continuous random variables? What does the shaded area represent? Good. So I would write that as a probability x is less than or equal to 5. Or the probability x is less than 5. Either one. The equality part, remember, for continuous doesn't matter. What would this represent? Oh, I got to bring it to me, Sejun. You can get it back from Mr. Peterson after school.
Wow, Mr. Rogers, you're so lame.
I know. I am a terrible, terrible person.
If he didn't say sorry, all the criminals on still.
Well, if someone's phone ring, I have to take it. It's supposed to be off and not on your person or in your bag. Turning themselves on. I felt bad for some 9th grader. I don't know who he was, but I just walked in the restroom and he's on his phone. So I took his phone and then I forgot to ask his name. So I don't know whose phone I took. I just gave it to Mr. Peterson and we figured he'd want it and he'd find it that way. Anyway, what did I just write the probability for? So that would look like this. All right, how much time do we have? Well, we're down to 14 minutes. Maybe I should pick up the pace. Calculate probability from a discrete random variable probability distribution. That sounds complicated, but it's not. It's not a test question, but if it was, what goes in that last blank? And so what's the probability that x is less than 1? 0.1. What's the probability x is less than or equal to 1? So it sounds a lot more difficult than it is. What's that? Not bad. Not bad at all. Is everybody good? Find the mean and standard deviation of a discrete random variable. So this occurs during the multiple choice section. So I don't know if you're finding mean by doing what we wrote down before. Or if you're finding mean by using your calculator. So if you're using your calculator, let's look at how to do that again real fast. You might put, or not might, you would, put the values that x can be in L1. You would put the probabilities of x in L2, and then do 1 var stat L1 comma L2. That will give you mean and standard deviation.
What's the difference between 1 var stat and 2 var stat?
2 var stat is going to give you more calculations that we'll use later. But some of the things it gives you is it gives you the sum of x, it gives you the sum of y, it gives you the sum of x times y. But what it means is 1 variable statistics and 2 variable statistics. All right, is everybody good with that one? Good, me too. Use a z-score to calculate probability. So you can, oh goodness, that just makes me think. I'll have to make a table A for everybody. You can use table A or your calculator. And I might give you like the probability that z is greater than 2. So for that, if you're using table A, remember it gives you values to the left. So you do 1 minus the probability z is less than 2 to find that. Or, since you know that the standard normal is symmetric, you could just look up -2, and then that's the same thing as greater than 2. Less than -2 is the same thing as greater than 2. Use the symmetry to your advantage. Use a normal distribution to calculate probability. So I might give you a normal, mean 6, standard deviation 0.2, and tell you to find the probability x is less than 4.9. So again, you can either use the z-score in table A or you can use your calculator. If I was going to find the z-score, it'd be z equals 4.9 minus 6 divided by 0.2. So that's what, negative 1.1 times 5 is negative 5.5. Holy smokes, there's like no chance that's going to happen. Probability 0. I'm 5 standard deviations away from the mean, so that's not going to happen. It could happen. People win the lottery. It's just not probable. Highly improbable. Do I need to go over that more?
What do you do with your calculator to find that? Like, what do you use for?
Let me see. Doing your homework, I've been doing z-scores and using table A. Normal PDF. Yeah, you want a normal PDF. And then it'll queue you for the values that you want.
Thank you.
You are welcome. On your calculator, it's a normal PDF. I said that for the video.
For the video.
Yes, because when I walked over there, I don't know if you could hear. Use a binomial distribution to calculate probability. So again, you can use the formula or you can use your calculator. This is in the multiple choice section still.
We can use my calculator, right?
You can.
Do you use binomial CDF?
Ben, it depends on what the question is. If you're calculating the probability that x equals 4, then you'll use the PDF. If you're calculating the probability that x is less than 4, then you would use the CDF. If you're calculating the probability that x is greater than 4, then you would do 1 minus the probability that it's less than 4.
We still use a CDF if there's like less or equal to exactly. We still use a CDF.
Right.
For the big thing.
Mm-hmm. Are we all good?
Wait, the order that you put the variables in
Yes.
on PDF, that's the same, right?
Yes, it's the same. And it's NPX. N is the number of trials, P is the probability of success, and X is the number that you want. So I said
Okay.
so back here I said like the probability X equals 4. That means I would have to have at least 4 trials. So N could be 4, 5, 6, 7, whatever, and probability's fixed, whatever it is. And then yep. All right, we're into the 5 free response section. And this is where the questions are really easier than the other questions. I'll probably just start getting old AP questions to use. That will be more fun. All right, discern between continuous and discrete random variables again. So we don't need to dwell on that one. Use a linear transformation to find the mean and standard deviation. And we wrote those formulas down before. I can. That was quick. I'm going to give you some data, and you have to create a probability distribution. And from your probability distribution, you're going to create a probability histogram. And then you're going to calculate some probabilities. So let's make up some numbers. F stands for frequency. So let's say I rolled a die 5 times. What are the possibilities? 1, 2, 3, 4, 5, and 6? All right, and then let's say that I got 2 1s, 2 2s, and a 4. And I want to calculate a probability or make a probability distribution from this. So I would list my X values. And my probability is going to be the frequency over the sum. So the sum was 5, the number of times I rolled it. So from my experiment, the probability of getting a 1 is 2 out of 5, or 0.4. The probability of getting a 2 is 2 out of 5, or 0.4. The probability of getting a 3 is 0 over 5, which is 0. The probability of getting a 4 is 1 over 5, which is 0.2. And 5 and 6 are both zeros over 5. So that is the distribution. The histogram would look like this. I would have my values 1, 2, 3, 4, 5, 6. And I'd put some title down here. Over here I'm going to label this probability. And 0.4 is my highest, so I'll make that 0.5. And I'll count by 1s, 4, 3, 2, 1. So I would have at, oh, I missed it. That's too bad. I'll make these two the same. And those would be here. And then the probability that X is greater than or equal to 5 is equal to what? 0. Just add up the 5 and the 6. Is everybody good?
It's hard to get back to like when it's on 1, 3, and 6. Will you still like be like, oh, this is a histogram?
Well, I'm giving you the data.
Oh,
I'm giving you the data. You're not creating the data. I give you data. Find the mean and standard deviation of a probability distribution. So if I went back to this, then the mean mu sub x is going to be 1 times 0.4 plus 2 times 0.4 plus 4 times 0.2. I won't put the zeros in there. So that's what 0.4, 0.8, and 0.8. So 1.6 plus 0.4 is 2.0. And then find the variance would be 1 minus 2 squared times 0.4 plus 2 minus 2 squared times 0.4 plus 4 minus 2 squared times 0.2. So that's negative 1 squared is 1. 1 times 0.4 is 0.4. And 2 minus 2 is 0. Squared is 0. 0 times 0.4 is 0. That worked out nicely. And 4 minus 2 is 2. Squared is 4. 4 times 0.2 is 0.8. 0.8 plus 0.4 is 1.2. So the variance is 1.2. So the standard deviation is the square root of 1.2. 1 point something. I'm going to say 1.1. Everybody understand this slide, Brian?
Can you use one word as fast as
You could as well. I'm pretty sure I tell you to show your work, So I still need some annotation on how you're doing it. What's that?
We have to do it that way. We write one.
Remember what I told you? You could write it with ellipses so that you show you understand how to do it and still use your calculator. Because that's what they want to see on the AP exam, is that you understand how it works. 1.1's right, Mark?
1.095.
Oh, I'm going to go 1.1 then. Use binomial and geometric distributions to find probabilities. So you'll have to determine whether or not it's binomial or geometric, but that's easy to do. The bins and the bits. Binomial, you have a fixed number of trials. Geometric, you're looking for first success. And then calculate probabilities.
When
And-
calculating those probabilities, can we use our calculator, or again, do we need to write the formula? Or can we just use our calculators for those?
You can use your calculator, but show your calculator work. Yep. Show your calculator work. All right, that's the end.
Yeah, we only have a minute left.